Okay, welcome everybody. My name is Dr. Juan Pinheiro. I'm an associate professor and extension dairy specialist at the Department of Animal Science, Texas A&M University. Thank you for joining today. Today we will be talking about strategies to improve the nutritive value of sorghum silage and just some homekeeping recommendations. If you have any questions, please type them in the Q&A box and we'll try to answer all those questions after the presentation. If not, you can feel free to email me and I can answer those questions later if we don't have time. So with that, thank you, Gustavo, for the invite, and thank you everybody who is joining the call for being here. And I'll go ahead and start with the presentation. So the first thing that we wanted to assess basically what was the problem. And this started as an assessment of a regional problem in Texas. But as we started working with this, we understood that it's not only a national problem, but also a global issue, right? And what you can see here on the left is the Ogallala Aquifer, right? This is a huge body of water. What you see here where it says SD, South Dakota, is a state that is very close to the Canadian border. You have South Dakota, then North Dakota. And if you pay attention, this aquifer extends from South Dakota all the way south to Texas and New Mexico, right? This is one of the largest aquifer in the US and actually in the world. And we have two very big aquifers in the US that the levels of the water they have are severely declined. One of them is this one that is called the Ogallala Aquifer, that is called also the grain basket because a lot of the crops that we produce, the water comes from here. The other one is the California Valley Aquifer. For the sake of simplicity, I'm only showing this, but in the colors, what you can see is the decline levels of the water in this aquifer from 1950 to 2007. So the more purple, the more intense the color, the more that aquifer level has been declined. Talking with dairy farmers and anecdotally, some of them, they have gone from producing corn on 90% of their land to being able to produce only on 20% of their land. And we've been going from irrigating a full pivot circle with 120 acres to now sometimes not being even able to irrigate a quarter pivot circle. So in this study, what they predicted is that from when it was published in 2012 to 2050, we will lose 1/3 of the irrigated land in the southern Ogallala Aquifer. The second problem with this is the frequent droughts that we have in the US. One of the most frequent ones that we have was in 2022. In this area, the price of corn silage skyrocketed. In some places, it was $120 a ton. Some dairies were shipping corn silage from over 300 and 400 miles when this happened. So this is a matter of when we'll have the next drought. We're always in this area in a abnormally dry or moderate drought in best case scenarios. This year, it was an exceptional drought. And the third issue that we have been dealing with recently is increased input costs. So that's fertilizer costs, seed costs, and so on and so forth. So to put this into perspective on how big this is for the country and worldwide, it's not just the US. You go to Mexico, Torreon, they have issues with water scarcity. You go to Argentina, when we have the drought, there were severe issues with water scarcity and also forage production scarcity. Western Europe, Italy, Spain, this is a worldwide issue that is threatening forage production and the dairy industry. About 40% of the milk production, 30 to 40%, come from states that have issues with water. Take California, state number 1 in production. Texas is now number three, New Mexico, Western Kansas, Arizona, and so on and so forth. So regarding the increased input cost, what we have seen is not only in fertilizer, but also herbicide cost. And while this occurred for most crops, we still see that the cost of these inputs tend to be lower for corn. For seeds, basically the price of seed, at least here in this region of the US, is 1/3 of a price of a corn seed bag, and you can do triple the amount of acres. So the seeding per acre cost is roughly 1/10 of the cost of doing corn silage. Fertilizer costs are also lower, and herbicide as well. So very roughly, you spend half or 60% less with sorghum silage compared to corn. So we saw that opportunity as well. But after seeing this, after seeing the issue, we also try to understand better what is the need. And this is something very important when you try to determine a forage production objective, that you understand, whatever you are in the industry, what is the need of your client, right? And one way to divide this is in two axes, right? When we think about forage production, yield and quality. And of course, we want to be in this quadrant as much as possible, right? And with corn silage, when you do have the water, when you do have the appropriate temperature as well to produce corn silage, it's very easy to see this quadrant. That's why in this region in Texas, 80% of the silage we feed to lactating cows is corn silage. That is why it's the main silage fed to dairy cows in the world. There's a reason why that happens. The problem is when you don't have the water, when you have frequent droughts, when your irrigation water well capacity is declining, when you have heat stress issues, when you have disease issues like it happened in Argentina earlier this year with the corn stunt disease transmitted by leaf hopper, all these things make you think really hard about trying to minimize risk and have a more diverse forage production system, right? So ideally, we would want also that in our forage production system, have build more resilience, try to have good water use efficiency. What do I mean by water use efficiency? How much yield you are obtaining based on how much water you are using, right? And not just the yield, but also digestible nutrients. How digestible is that forage that you are producing? And also consider harvesting logistics, right? What is your harvest window? What access you have to processing technologies? All these things you have to consider when you're trying to determine your forage production objectives, right? Then we have a quadrant that is quite obvious where we don't want to be. In this region of Texas that is a semi-desert, we have about 250, 300 millimeters annually, about 10 to 12 inches of rain annually. So this would be for me, for instance, trying to do corn on dry land, on a land that is not irrigated. You will get low yield, and if you get a crop at all, which you may not, and low quality. And then you have the other two quadrants, right? Where you can be, if you have low forage inventory, you will prioritize focusing on producing forage that will give you high yield. Or if you do have good forage inventory, you could focus more on quality. An example for this one could be, say, BMR dwarf sorghum silage that will give you great fiber digestibility. It's a dairy feed that is used quite often here in the Texas Panhandle, but you don't get great yield. In the opposite here, you can have, say, a sorghum Sudan grass, a non-BMR, that it doesn't have good fiber digestibility, but it gives you great tonnage. Some hybrids can give you higher tonnage than corn silage in the area, but it may only help you to feed dry cows or replacement heifers. It will not be good feed for lactating dairy cows because it may not have good fiber digestibility. So this is the first thing that I wanted to make very clear. This is something that we wanted to understand better, what was the need in this area. and it's quite diverse. What we see the most because of the water scarcity, that the priorities are number one, yield, number two is fiber digestibility. Then, of course, if they can get starch, that is digestible starch, that is also an advantage because they can decrease some other feed costs, and the same with protein. But in an extreme scenario, the main priorities are number one, yield, number two, fiber digestibility. We have record low, well, not record low, but very low corn prices nowadays. So you can supplement and increase dry ground corn and feed some, for instance, the BMR male sterile sorghum, which is something that I will be talking about later today. So in summary, when we see sorghum as an alternative crop to corn, what are the advantages that we are seeing? Well, it is a drought tolerant crop, and there are physiological explanations for that. If you have questions, we can discuss that after the presentations, but I will not cover that right now. It is a water efficient crop, and it can be and it will be more water efficient than corn in water limited environments. Yes, when you do have the water, corn in many hybrids will be more water efficient or could be more water efficient than sorghum. But in regions that you have water scarcity, sorghum will outperform regarding water use efficiency corn. And it has lower input cost. What are the disadvantages? It has lower starch digestibility, lower fiber digestibility, okay? With some exceptions. Which are those exceptions? We have evidence, we have data that BMRs compete quite well with conventional corn silage regarding fiber digestibility. Of course, there's a lot of variation. Not every BMR is the same. Some non-BMR sorghum can have better fiber digestibility than BMR, but that's not the rule. On average, the rule is that BMR sorghum silage is more digestible on average compared to non-BMR sorghum silage. And we have evidence to show, and we will be sharing that today, that it can be at least partially replace corn silage. You will have to do adjustment in the diet, but it can be replaced. So for the next two parts of the presentations, I'm going to divide it into, this part will be about increasing fiber digestibility. The last part will be about research efforts that we have done regarding increasing starch digestibility. Regarding strategies to increase fiber digestibility of sorghum silage, a very brief recap for someone that may not be so familiarized with some concepts in nutrition. The reason why we care about this is that for every 1 percentage point increase that we have in fiber digestibility, we can increase intake. We can increase dry matter intake by almost 0.4 pounds a day. For anybody that is not in the US, that would be a little bit less than 0.2 pounds. It would be 0.17, I'm sorry, 0.17 kilos. If we increase 1 pound of dry matter intake, that may result roughly in 1.5 pounds more of meal yield at 4% fat. So why is this? Again, a very brief recap is because one of the mechanisms of dry matter intake regulation is the mechanical inhibition, right? And fiber digestibility is key to prevent this from occurring, right? From limiting intake because of this gut feel, right? So if we have a forage that has low NDF digestibility, it will increase gut feel and reduce intake. There are other mechanisms of feed intake regulation that we can discuss later, but I will not be talking about those, at least in this slide. Now, when we look at sorghum forage trials, there are two very big in the US. One is in Florida, the other one is in Texas, at least that I'm aware of. Those are two of the main bigger forage sorghum trials. So basically, this is a review from Ferraretto team. Pupu did this review, and they had 24 trials with 437 hybrids from 2008 to 2019. And over there, they can do two summer crops. They can grow in spring and summer. Here, we cannot. We can do only one. And then they were looking at forage sorghum and sorghum Sudan grass, and then they have BMR and non-BMR. So very roughly, what you see when you compare again BMRs with non-BMRs, you see about a 5 percentage points increase in NDF digestibility after 30 hours of incubation. With the formula that I shared in the previous slide, that will equate to roughly an increase of 2 pounds in intake and 3 pounds in milk. Regarding the trials that we have done here, we have been doing it for over 20 years. Our agronomist, Dr. Jordan Bell, has the lead on that. I just summarize here 4 trials, basically from 2018 to 2021 with 268 hybrids. And we have forage sorghum hybrids. There's sorghum Sudan grass. We have early, mid, late maturity. So very different type of sorghum. But when we compare from all that pool, all the ones that are BMR and non-BMR, we see very similar data than the one was obtained in Florida. It's about 5 percentage points increase in NDF digestibility. This one is 48 hours incubation, but still. And also we see decreased lignin, and perhaps I should have explained better what I mean by BMR. BMR is brown midrib. Hybrids is basically a mutation that occur in these basically sorghum hybrids. It can occur in different chromosomes, but what it does, the consequence is that it has less lignin production, right? That is the part of the fiber that is practically undigestible. So with that is at least explain in part why we have increased digestibility with these hybrids. We also have less standability because when we don't have this, if you have a BMR and it's a very tall plant, you may have some more risk for lodging. Then we see again similar results, which will lead to an increase about 1 kilo in dry matter intake and almost 1.5 kilos in milk production. Now, taking this not only from forage trials that send samples to do in vitro analysis, when we look at the meta-analysis that actually fed of studies that fed BMR sorghum silage, when it was compared to conventional sorghum silage, we see that there was an improvement in digestibility. In this meta-analysis with 9 studies, about 7 percentage point increase in NDF digestibility. And what they saw here is that there was an increase in 1.8 pounds intake and 3.6 pounds in of milk production, right? So we're talking about here a little bit less than 1 kilo of intake and roughly not almost 1.5 kilos in milk production, right? So similar numbers to the ones that we were discussing previously. Now, this meta-analysis from these 9 studies took it to the next level and compare BMR sorghum silage with studies that were comparing BMR sorghum silage and corn silage. And what they found basically is that there was non-significant difference in intake and there was non-significant difference in milk production. And NDF digestibility was quite similar, right? It was 55 for the BMR sorghum silage and 53. Now, in these studies and the studies that we did that I'm going to show later, when you partially replace corn silage, it's not just that you take out corn silage from the diet and put sorghum silage. You need to change other feed ingredients. One of those main changes that we do is we increase another source of starch in the diet, namely in this area, dry ground corn. And that is because you may have lower starch in the sorghum and lower starch digestibility, especially depending on which grain processing technology you use, right? So that's very important. It's just not replacing it or partially replacing and not doing any other change. You need to do adjustment in the diet. Now, after that happened, when we started doing this research, we were struggling to process the berries. We started in 2021. We did in 2022 a research that I will share later with the berry size, and we were using corn kernel processing technologies and settings. And even with bigger berry size, we were failing to see improved processing and starch digestibility because the size of the berry. We'll discuss that later, but it's 5 to 10 times smaller than corn kernel. So because of that, we started looking at, okay, let's produce a forage sorghum that doesn't have any grain, okay? So we started looking at male sterile sorghum hybrids, BMR, and started looking first at the research from New York. This is from Thomas Kilser, and what he was demonstrating is that from boot stage to 6 weeks after boot stage, what you see is a five-fold increase in sugars. So here it increased roughly from 3.8% to 18.9, almost 19% in sugars, okay? Water-soluble carbohydrates. So that was one advantage. The other one was that you have an increased harvest window. Something that was happening to us is because we couldn't process the grain in the sorghum silage appropriately, we were trying not to harvest at hard dough stage, but going earlier at soft dough stage, when the grain has more humidity and the starch is more digestible. So we were trying to compensate the poor processing by having more grain humidity and harvesting at an early stage. What is the problem? That at soft dough stage, your harvest window is 1 week. When you grow something like a BMR male cereal sorghum, you can take your harvest window from 1 week to perhaps a month. It depends when you harvest and the hybrid, if it is an early, mid, or late maturity hybrid, but you significantly increase that harvest window, and that facilitates logistics. So it is a very important advantage. It may have also decreased lodging risk. You don't have the weight from the berries in the top of the plant. So if you're producing a plant that is, say, 8 foot tall, almost 2.5 meters, you don't have all that weight from the grain. And you have some high yielding hybrids. Again, some sorghum hybrids, they can yield in this area more than the corn silage that we produce in this area. So what we did, and this study was in 2022, is basically we divided half a pivot table in two quarters. And the west quarter, the one that was on the west, we had male sterile sorghum, right? And we had a BMR and a non-BMR. And on the east, we had seed-producing hybrids, right? Also, 2 BMRs and one that was non-BMR. Now, this was in a commercial dairy farm. So where you see the gray area, dairy farmer had another sorghum hybrid. So we have some cross-pollination with the male sterile hybrid. That's why you will see some higher starch levels in the results that I will share in a bit. But still, regardless of that cross-pollination, you see the male sterile here develop some starch because it did develop some grain, not much. You still see the trade-off, and this is constant. When the plant doesn't develop grain, it doesn't translocate the sugars produced from photosynthesis to the grain, so it accumulates the sugars. And this was demonstrated by Kilser first in New York, and we repeated it here. It's quite constant, and there's plenty of research showing this. Also for biogas production, they show this for sorghum. Anyways, so this was quite attractive in that sense that we could produce a carbohydrate that is readily available for cows. Now, while we got excited about that, we were hoping that we will keep those carbohydrates when we ensile the BMR male sterile. If we will have 18%, we were hoping we could keep it at 10% sugars. For most cases, that did not happen. We had anywhere between 3 to 8% sugar, so it decreased more. So a lot of those sugars will be used during the fermentation process, during ensiling. The other challenge that you have when you produce these male sterols is that because you don't have the grain, you don't have the driest part of the plant, which means that it is more difficult for this plant to basically dry down and have a dry matter between 30 to 40%, which makes dairy farmers, especially in this region, quite nervous because they're worried about fermentation issues and leachate risk. So we try to work on some strategies to decrease that. The main one that is being used is basically, again, this is a semi-desert, so they just cut it in the morning, they let it dry, they wilt it, and then they pick it up in the afternoon and they chop it. But also you can see that some hybrids, they achieve a dry matter very close to 30%. Actually, you can achieve 30% dry matter depending on your hybrid choice. For instance, if you start early in the season and see the early maturity hybrid or mid maturity, you have plenty of time to wait for that hybrid to dry down and achieve maybe a dry matter of 30%. Whereas if you see it late in the season and your hybrid selection is a late maturity, that hybrid will be more difficult to dry down. Another question we get is, why do BMR male sterile sorghum and use forage sorghum and not just do photoperiod sensitive? The reason for that is that with photoperiod sensitive hybrids, they don't dry down as much as the forage sorghum BMR male sterile sorghum hybrids that we have been using. They stay more between 20-23% dry matter range. So these are some of the strategies that we summarize in one of our articles. How can you decrease the risk for leachate production? And there are many studies and there are different curves. There are quadratic curves, there are exponential curves. The oldest one is a linear regression analysis that they did trying to predict how much leachate production you will have. And like George Box mentioned, the statistician, is all models are wrong, but some are useful. And the usefulness of all these models is that you see two things. Number one, the trend, and where it starts is it starts at 28% dry matter, and when you go lower, so here we have the complement, so it will be 72% moisture, and it always goes up to that point, but it increases the rate. So from, if you are between 70 to 75% humidity, so 25 to 30% dry matter, the risk can be quite low. So if you are very risk aversive, which is the case in many dairy farmers here, you may not want to take any risks. So you may just, even at this dry matter, cut, wilt, and chop. Some don't. They are not so risk aversive and they take some risk, but they take calculated risk. So what they do is they may chop here between 25-30% dry matter, but what they do is they are careful with the forage processing. So don't chop too finely. And we saw that if you chop from a 1/4 inch to a 3/4 inch, you can decrease leachate production from 15 to 30%. We've been doing some research with that. So the processing that you have, the more you chop the fiber, the more you increase the leachate risk. The packing density as well. What type of silo are you doing? Are you doing a drive over pile that is higher than 12 feet? Okay. Silo configuration. We don't see tower silos anymore. But if you will have a tower silo, that would be high risk because you get a lot of pressure. So there are many variables that you can use to decrease risk, and you will have many dairy farmers. Some are very, very risk aversive. So if they are, then the second one, cutting and drying before chopping, that is the most commonly used approach when they do this. So what we did then is, okay, let's do a feeding trial with this. We started doing agronomic trial and sending all these samples to the lab. And then we did a feeding trial in a dairy that we have in Central Texas with 48 cows and 3 treatments. So there were 16 cows per treatment in 4 pens. Of course, everything randomly allocated. And what we tried to do is have diets that were similar in starch content, forage NDF, similar crude protein, and so on and so forth. And basically, this is what we achieve, right? I'm summarizing this, but if you have more questions about the study, we can discuss it after the presentation. These are the results. Basically, what we were doing is we were replacing 25% or 50% of the corn silage in the diet with male cereal sorghum silage. At the same time, we were increasing dry ground corn to adjust for the decreased starch and energy in these diets. That was the main change. There were also some changes in whole cotton seeds and hay to maintain similar forage NDF in all three diets. What was surprising to us is that we were doing a study where we were shooting for bioequivalence. Basically, that this treatment will be similar, or biologically speaking, right? Because our hope was, if they will be, then this is feasible. We can partially replace corn silage with BMR sorghum silage. And to our surprise, it was not just bioequivalent. We have to change the analysis, and because we saw that actually the not only that they were not bioequivalent, but there was a significant difference in favor of partially replacing corn silage, at least in this dairy. This is one study, but at least in this study, there was an increase in intake, about 6 pounds. That's quite a significant effect size. And that translated in increased fat and protein corrected milk production of 9 pounds. In other words, this was what we usually call energy corrected milk. Now we're using fat and protein corrected milk. This was because these cows were producing more milk, right? Of course, we will expect more lactose yield. No significant difference in protein percentage, same in fat, no significant difference. There was a tendency, p-value of 0.07, for increased fat in diets where we were partially replacing corn silage with sorghum silage, again, adjusting for other feed ingredients. And there was increase also in protein yield. What was interesting to see is that there was also a reduction in the MUNs in this treatment, and we're trying to understand better why this happened. So we checked also dry matter intake on as a percentage of body weight, and basically all these treatments were balanced, right? Basically, we have multiple crossbred cows in this experiment, and they were balanced by lactation number, but also by body weight. But we saw that they have increased dry matter intake, right? No body weight change at the end of the trial. And then we moved on to doing research to increase starch digestibility. And with this, what we saw is that there are three effects that are the biggest one when it comes to increasing starch digestibility. One is plant maturity, but I could use here grain humidity instead of plant maturity. So basically, you will see more digestibility at soft dough stage compared to hard dough, compared to physiological maturity. As the plant matures, the grain starts losing humidity. It is also, once it gets to physiological maturity, decreased size, and it starts becoming more vitreous and less digestible. Grain processing is another big one. And the other one is in silane time. We also did studies to assess berry size, the effect of berry size, but we didn't use sorghum processing technologies. We used technologies designed to process corn. So we failed to see an effect in that study. And we also tried to assess grain to stover ratio. We haven't done a study yet to assess starch composition and work with some waxy sorghums. Some of the studies that have been done here, this one was in 2018. This is an image courtesy from our agronomist, but the beef extension specialist was involved in this study, and the student was called on. Basically, what they did is they have sorghum harvested at soft dough stage or at hard dough stage. So these two columns, the green and the purple columns, are harvested at soft dough stage. The red and the blue are when they harvest at hard dough stage. The blue one is that they crack the corn. The red is whole corn. And here the green one is, sorghum. The green one is cracked sorghum, and the purple one is whole sorghum. So what you see here, one of the biggest effect is that plant maturity matters. What you have on the y-axis is the rumen degradability of that starch, right? And you see almost a 30% increase when you compare soft dough to hard dough stage. The second thing they wanted to do, and the reason why you see these columns 4 times, is that they have on the x-axis in silent time. So they have 0 days, 30 days, 60, and 120 days. And I know there's some study in Argentina that they were also looking at this. What happens if you prolong that in silent time? They took it to 12 months, 1 year. What will happen with that starch digestibility? And it increases. Even if you have poor processing, you can see here that when you have whole sorghum berries harvested at the hard dough stage, you see some increase. But at least here at 4 months, you were still 15, 20 percentage points lower than if you will have harvest at soft dough stage. So the effect of the plant maturity is quite important. Before, again, we will go to soft dough stage because we couldn't process the grain. There's also some research from Florida. This is from Cody Macari, working for Luis Ferrareto when he was over there. Now he's in Wisconsin. But anyways, what they did, what Cody did is he was cutting the berries in 2 pieces or in 4 pieces, right? And he will see that basically you see almost triple starch degradability after 7 hours incubation compared to whole berries. So it also matters the processing, right? So again, if you forget everything I have said, the 3 most important things, that the 3 biggest effect that we have seen is grain humidity, berry processing, and now I'm gonna discuss in silent time. That is also a big one, especially if you harvest at hard dough stage. So what we wanted to do is look at the effect and the interaction, especially the interaction of increasing berry processing score, right? And starch digestibility through using a sorghum kernel processor and settings that were designed to maximize the sorghum grain processing, and also assess the interaction with ensiling time. So I told you before that we couldn't process the grain, but received a call last year, November, that there was a processor that was breaking 100% of the berries. And I say, I don't believe that. I need to see it. So we went there and we did a study. Basically, when they were harvesting, we divide the field in 9 parts. We randomize them. We have 3 replicates basically, and we did 3 treatments. We were cutting 8 inches from the soil, so a low cut, 48 inches from the soil, and we were using this kernel processor or we were removing it. And then we saw for 0 or 3 months. Now, the design of the KPs, that I don't have the data because it is intellectual property and it will be patent on February. But it is a very aggressive design without a doubt, right? I don't know exactly what it may be. It may have more teeth per inch. The corrugation for sure will be different. The settings are also different from corn processing. For corn, we typically use 2 millimeters. Here, for the experiment, we were using 0.5 for the one that we did last year. With experiments that we are doing nowadays and what they are doing in the field, they are going more to 1 millimeter to not have such a loss in harvesting efficiency. But this was the results that we saw basically. In the 3 treatments that we have, the first one was the low cut with no kernel processors. 85% of the berries were intact, 15% of the berries processed. With the processors, it went to 1.6% of intact berries. It was not 100% processing, but it was pretty darn close. 98.4 is pretty darn close to 100% of the berries processed. Then we lift up the cut height to 48 inches. It would be like 1.2 meters. And it went to 100% of berry process. Of course, nobody will do this in the field because you will leave a lot of biomass. But we just wanted to answer a research question: is if you lift it up, can it increase the processing and the starch digestibility? So this is what we look when we look at that interaction, right? That it was significant of the treatment and the ensiling time. So if you will wait 3 months, you will see an increase in starch digestibility. Say this is rumen in situ starch digestibility after 7 hours of incubation from say 35% to 66%. And this was the high cut. When we look at the low cut, very similar. It reached, if I recall correctly, this one was 66%, this one was 67%. So there was only 1 percentage point difference in situ starch digestibility, which means, yes, perhaps increasing the cut height and having a higher grain to stover proportion will make it easier for the equipment to process that berry. But with this aggressive technology, it was not necessary. It didn't have a significant effect on increasing when you compare these two bars. And the other thing that we saw is that when we did not process, the ensiling time did not help increasing starch digestibility. So here we have 85% intact berries. Lastly, and I don't know how I'm doing with time. I think I'm still in track, but we look at a study. This is going back in time. This was the study that we did, the first one in 2021, seeing berry size. And the question was, can we increase the processing and the digestibility, starch digestibility, by increasing berry size? So we used 2 harvests to compare. These are from Richardson Seed Company. But basically, this one F10 has close to 3 millimeters diameter, and this one, the berry diameter is closer to 4 millimeters, right? So we wanted to compare nutrient composition, the berry processing score, and starch digestibility. So what we did, basically, this was, again, another trial that we did in a commercial dairy farm. And we were able to, at the beginning, randomize both, where we will have the corn and where we will have the sorghum. And here the dairy farmer, he was doing sorghum Sudan grass millet mix. So he had 2, sorghum Sudan grass and millet. But he let us have some plots. So we also randomized the plots here. So we have one hybrid with big berry size and one with small berry size. And we harvest that at soft dose stage at 30% dry matter. And back then, when we did the study, we already knew that we had the option to increase berry processing through being more aggressive with the harvesting technologies. You can reduce the theoretical length cut, or you can reduce the chop length, in other words, and you can set the KPs tighter, and you will increase berry processing score. This one is the 2.36 sieve. I will be showing some results with that sieve and some with the 1.7. But we didn't take that approach back then. We thought costume harvesters will not do it. It will lose efficiency, harvesting efficiency. It will burn more fuel. It will slow them down, and it will reduce the life of the kernel processors. They won't do it. And I believe I was very wrong back then, and I should have started exploring that before. Luckily, we started last year collaborating with this company. But anyways, our goal back then was not to increase the processing through being more aggressive with the processing technology, but increase it through increasing the berry size, with the hope that then with future hybrids, we could continue increasing the berry size. So this is how it looked. This is a view that I took with my drone, basically. The plants that you see that look more white here, this is the one with the larger berry, is the F24, and that's the color of the berry. That's why it looks white. The other one that looks a little bit more reddish, that's the one with the smaller berry, is the F10. And we had 10 plots here. This is what was part of the main experiment, but then we took samples from the adjacent corn silage, which was subject to the same irrigation amounts, right? So we did that comparison as well. And we had this at two dairies, but I'm going to present data from only dairy one. Why? Because basically we had good pest control here, good weed control, and we harvest when we wanted to be harvesting. Back then we couldn't break the berries appropriately, so we wanted to harvest at soft dough, and so we give high priority for analysis. Dairy 2, we had high weed pressure. It was heavily infested with sorghum aphid, previously known as sugarcane aphid. And we know that when you have this infestation, it can affect yield and it can affect quality, right? This is a study from our retired extension entomologist. And basically what he was seeing is when you have 70-80% of the leaf area infested or damaged with this aphid, you basically lose half of your yield potential. So the other thing that it was harvested really late. It was passing the hard dough stage, reaching physiological maturity. The plant was already being almost all yellow. So we gave basically low priority for analysis. So back to dairy one, this is how it looked, the aerial view. This is the area that was harvested from the forage that the dairy farmer had, that it was a sorghum Sudan grass millet. And to prove the point that dairy farmers couldn't care less about the berries in the sorghum, in this particular dairy farmer, he was harvesting at flowering stage. It was an 8-foot tall plant, so very high yielding. It was more high yielding than corn, but they will cut at flowering. Then in the morning, let it dry and pick it up in the afternoon when it's between 35-40% dry matter, and then chop it and ensile it. So this is something constant that we also see, right? When you compare corn with sorghum silage, not only the grain is 5 to 10 times smaller in sorghum than corn, but also it has less grain proportionally. So in corn plants, we see about 45% of the plant being the ear, right? Being the reproductive part of the plant. Whereas with forage sorghum is roughly 30%. Because of that, then you will have with forage sorghum hybrids, you will be in the 20s in starch, whereas with corn, you can be in the 30s, low, or even with some corn hybrids, mid 30s in starch concentration. The other thing that we did is we actually wanted to see if F24 was bigger, significantly bigger than F10. And what we found is that basically 90% of the berries were above the 3.35 sieve, whereas F10 was only 40% of the berries. However, when we look at berry processing score, there were no significant difference on the 2.36 sieve and on the 1.7 sieve, apologies, on the 1.7 sieve, and then the 2.36 sieve, it was opposite to our hypothesis, which was probably not a good hypothesis to start with, because what we hypothesized was that the bigger berry will break more and pass more through a sieve of 2.36 millimeters. Whereas for a small berry, arguably it will have to be broken in less pieces to be able to pass through those holes. However, we were still hopeful because we said, well, even if that it's opposite to our hypothesis, maybe there's less intact berries with the F24, so maybe we see some differences in starch digestibility. And the results, not only they were non-significantly different, they were almost the same, 59.5 and 59.3 starch digestibility in the rumen after 7 hours of incubations. When we compare it to the corn that was right next to it, it was 75%, and this is very close to the US average that we have. Now, recall the data that I showed you earlier. harvesting at hard dough with this technology and waiting for 3 months, we are reaching 66%. We're doing new studies now to see at 6 months and 9 months of ensiling time because of anecdotal reports from nutritionists of samples that have 8 months of ensiling time and are at 84% of starch digestibility. So some future directions, as I mentioned, we are looking at 6 and 9 months of ensiling time, and we are also looking at different roll gaps. We have 10 different dairies right now. So we will do about 100 samples assessing this technology. Something else that we have done is that because we were feeding BMR male sterile sorghum silage, and we will have to increase dry run corn, but we were losing a source of starch that it would be more digestible in the rumen. We wanted to do also some research with high moisture sorghum. And potentially, the way we did this was we were using a combine, harvesting the grain, and then using a bagger that will have some roller mills right here. However, we can make this much more simpler nowadays because you can use a chopper and just do a headlash, and you will achieve very similar results. And while it would be risky to produce some forages here in a semi-desert without irrigation, if you are going to produce something in dry land, something that you could produce and reduce risk is a grain sorghum that it has an ultra early maturity, because you need a good rainfall precipitation and good amount of soil moisture, and then perhaps with one more rain you may get a crop if you have 8 to 10 inches of water. So that's basically what we were doing. And the other thing that we assessed in the future was, can we do this sorghum grain in the corner of pivot circles? So leave the pivot circles to produce a forage that will give you good yield and fiber digestibility, and use the corners to produce a grain sorghum and focus more on the starch digestibility. With that, I would like to thank all the students that have participated here. Douglas, a PhD candidate, Arthur and the interns, all the agronomists that help with the studies, and the funding sources, and the dairy farmers that help with this. And Gustavo, I will be happy to take any questions that you may have in the Q&A box.
Very good.